Hello, so my name is Florent Thery. I'm working at Bullx in the parallel file systems team. So we are working on Lustre and administration tools around Lusters. And my presentation of today is about the work of this year about monitoring Lustre file systems. So the agenda, first I will briefly present Bullx and the extreme computing activity in Bullx. Then I will present the objectives of our approach and our development. And then I will go a little deeper in the architecture we have chosen and the metrics we have been selected. And I'll try to make a little example in order to see the benefits we can expect from such a monitoring tool. So Bullx, many of you may know now, I think. It's an actor of the HPC market, and we are a well-placed manufacturer in Europe. This year we have delivered several high-scale supercomputers, like the one from Meteo France with direct liquid cooling technology, and it's not a very fast supercomputer for now, but it's the first CPU-only supercomputer at Green 500 of June. And we have delivered some other supercomputers like for Sarah, Technical University of Dresden, IT4E, so there are middle scale supercomputers for now, but they are all planned for over 1 petaflop in future phases. Bullx is also, so in our team, a contributor in Lustre development. We are integrators of Lustre 2.1, 2.4, and the incoming 2.5 for the end of the year. That will be integrated in our future release. We have reported many bugs and submitted patches for them, mainly thanks to the static code analysis project on which we are using, called Coverity. So the goals of our approach. Lustre monitoring is a complex task, mainly due to the fact that you can find whatever information you want from Lustre, from running statuses in Lustre in the product file system. But the problem is that this information is really spread on every node in several devices, several subdirectories in /proc, and it's quite kind of hard to aggregate all this data, and to extract some information, for example, about a whole node or a whole file system, or to cross-reference data you can find about different OSTs or things like that. Then another problem is the fact that it may be hard to detect an abnormal situation, because abnormality or normality depends on what you expect and on the person who sees the data. For example, you can have your MDS that is overloaded for a few hours, and it can be a normal situation if there are many jobs making metadata, and on the other side it can be seen as abnormal if there is only one job running, or so it depends on the person who sees the data and on what is expected at this moment on the cluster. So for this reason, it may be hard to find one algorithm that could solve every situation, and we have to find some configurable and flexible mechanisms and easy extensible and changeable mechanisms in order to be adaptive to many contexts. So now a word about the goals that have driven us for our development. So our general goal is to be able to collect data on the nodes about targets, nodes, and file systems, and be able to display graphics with this data. This is the general goal. Another goal is to be able to raise alerts based on thresholds checking. Those thresholds will be configured by the administrator and easily changed, modified, added, deleted, depending on what he expects and what area he wants to focus on. And the third goal of our development is to have an implementation that is easily integrated in our HPC software base. So some design goals have been we had with our implementation, we made some design decisions based on this third requirement. Now, the functional objectives of our monitoring system. So we have basically three objectives. One is for live visualization of data. So this one can be achieved by looking at graphics and or setting alerts on one or another metric. So this can be helpful in order to find, for example, space saturation on one OST, why the space system is okay, but there is one OST is feeding weekly to others, and so we want to be able to see the situation quickly, visually. The second objective is for analysis. So one is more about yesterday on system really badly, and I understand why it's not very deeply defined, quickly find and hints in order to go the right way in the investigation without asking 3 or 4 hours asking what happened. And the third goal is for an easy configure alert system. This one can be, for example, you have a bad situation happening, and you don't want the situation to reproduce. So you will set up some thresholds on different metrics, on OST metrics or NVT metric, or on a node that you suspect being in a weird state, and so to be able to be notified more quickly if such a bad situation reproduces. So, a small word about the architecture. So for our collection mechanism, we rely on collect D, the collect D daemon. So data is picked from the /proc file system here in the Lustre plugin that we wrote. This plugin reads some files in /proc and extracts data about them, and then transmits this to the daemon. That transmits this to the network collect G plugin, and then all the data goes on the management node through a standard collect G mechanism. Up to the LAD'2 plugin that writes data in LAD files. Then this data can be displayed using the collection-free CGI interface. So this is a basic interface allowing you to visualize graphics with very few selection possibilities, but our goal was more to see if we could get some information and display it for first phase. In parallel of that, the Lustre plugin and the IO node is able to check for thresholds that could have been defined by the administrator, and if a threshold has been overtaken, it writes an entry in the syslog of the node, and then the information is relayed on the management node and treated by a SEC, so a simple event correlator engine. And if an entry matches one of the rules we have written in the SEC engine, an alert is raised to Nagios, so to the Nagios interface. And another place where we check for thresholds is on the management node, where LustreFS plugin is checking for all file system thresholds, and if the threshold is overtaken, it goes the same way through syslog ng, SEC engine, and Nagios interface. So yeah, this one is a bit the same that I've just said, but metrics are collected on each I/O node, so on OSS nodes and on MDS nodes, and the data is stored in one RD file for each target. So there is one RD file for each OST of each file system in the cluster, and one RD file for each MDT in the system. Then this raw data is consolidated and aggregated in two places. So on the first place is in the Lustre plugin. Each OST information is aggregated in order to have a node figure. So the data is added for each OST. And then this information is transmitted on the management node to end up in one RD file for the whole node. And the other mean of aggregation is the CGI script that visualizes information. This one displays one graphic per RD file, so you have one graphic for each OST or MDT in the cluster, one graphic for each node, because we had an RD file for each node, and an aggregation is made on the fly thanks to the LAD tool to have file system graphics. So here is a list of the metrics we are collecting for now. This is a list of metrics we considered would be good candidates in order to be able to troubleshoot some situations. So we have three levels of display for these metrics. The first one is for targets, the second is for nodes, and the third is for file systems. So some metrics are displayed for each type for each level, and some other ones, like for example the request mean wait time, is for a node. We have the information only for each node. And some others are only for targets, like for example the number of clients connected will be per MDT. So the other mechanism we set up is the thresholds mechanism. So thresholds are performed with configuration files. So the administrator can enable some thresholds, disable others, change value, and other things like that. These thresholds are by default deactivated, and the administrator must manually activate them if he wants to point to a metric or another one. Thresholds are, like I said earlier, are checked in two places. On Lustre plugin I/O nodes, so in the plugin that collects data from Sprock, the threshold is checked, and if it is overtaken, the alert is raised through the syslog mechanism. And the LustreFS plugin on the management node take a bunch of values of each metric of each file system metric, and does the same computing. It checks if the threshold is overtaken, and if this is the case, it throws it to Nagios via the stake engine. For now, we only define some maximum value threshold, so we are only able to check if a value is higher than what has been defined. So here is a list of the threshold we are defined currently. So the thresholds are a bit an image of the metrics that we collect. Some check targets information, other ones the node information, and a few of them are checking for file system metrics, so like the FS IOPS or FS disk usage. For targets, we have the OSS request wait time that we can set, and for target we have the OST disk usage, for example. And if threshold to deactivate one threshold, one just need to set it to 0, to set its value to 0, and it is not activated. So, small word about the benefits we expect from this this tool. I've taken a little example that's not an example from a production server, so as you will see, the performance, the absolute performance is really awful, but it was more to try to illustrate how we can use this tool to be able to pinpoint to focus on something something to when you are lost, you like to have directions, and so it gives you a direction. So let's say, for example, that the job takes an awful time to finish compared to the day before, where in 2 minutes it was finished. So the first thing we can see is the bandwidth. So this is a small file system with 4 OSTs. I don't think there is some in production servers. So if we look at the bandwidth, so yeah, this is really low, 6 megabytes per second for each OST, but it is equally distributed on all OSTs, so we can't find out any hint about this one. So we're going to try to some other graphics. On the IOPS side, we see that 3 of the OSTs are handling between 5 and 6 IOs per second, and the last one is more than 100. There's something weird. So there is something really bad happening in this. So we're gonna try to go further and see at the IO size, the mean IO size of handled by OSTs. And here we see that everyone is handling about 1 megabytes request, while OST 3 is handling 40 kilobytes per request. So at the beginning we had a situation where we had 24 megabytes performance, and we didn't know where it could come, and here we can point to Llama 7 with OST3 that apparently is doing something wrong, or it may not be the server, it may be the job. In order to go further, we will attain the limit of our monitoring tool, but now we can say, hey, Llama 7, tell me what goes wrong with you. So here's for the example for future works. So our tool is a very first shot tool for now. So our main goals for now will be to try to figure out the impact on CPU and memory on I/O nodes. We will try to evaluate if the metrics we have chosen are relevant for troubleshooting problems. And we will try to evaluate also if the RRG databases are relevant for data storage and for our needs. And so this will be a testing feature. And for enhancement, we would like to add support for the job stats feature in Lustre in order to be able to cross-reference information we find on the servers with what is going on the client side. So we will try to use the job stats because it's on the servers, and we don't like to impact performance on client nodes. So we try to stay on the I/O on the server side. We will have to work on a more user-friendly graph system because the collection tree is it displays all the graphs, but all in one bunch. So it can be hard to cross-reference between two graphs that are one at the top and the other at the bottom of the page. And the third extension that we would like to do is to enhance the thresholds mechanism in order to be able to, for example, to specify mean values that metrics must not go down. Like for example, in our example, we could have set a mean threshold on the I/O size to 50 kilos or something like that. And we could also try to make more automatic cross-referencing using more complex and sec rules. So as a conclusion, our tool is absolutely not a performance tool measurement because the use of RRD files, with the use of RRD files, you lose precision over time, so you can't expect some exact figures. But we will try to use it more as an help for analyzing and preventing odd behaviors by cross-referencing information and trying to extract tendencies that could be problematic depending on what you expect. Once we will have a good display mechanism, it will be easy to cross-reference information. A good point is that we are using some recognized tools in HPC world, and that tools that have proven good scalability and stability. And we expect this tool will be easy to configure and extend if we have more extended needs. Here it is. You have some questions?
Could you explain a bit more about the sequence event correlator? Does it just compare two values and just raise a warning when there's comparison of some threshold with something, or is there some other things that the SEC does?
Your question is about
the sequence event correlator, the SEC.
Okay.
So if you could explain a bit more about the functionality.
Yeah. So here, no, it's here. Yeah, so the SEC engine is an engine based on regular expressions. So you define some regular expressions about what you would want to pick in the syslog files, and if a rule matches one of your regular expressions, you can specify actions on what to do about this match. And so, for example, here we forward it to Nagios interface, but you could imagine to send an email to the administrator, or shut down the machine, whatever you want, for example.
Another quick question is that how much of data do you need to analyze?
How much?
What's the volume of generated telemetry data that you need to analyze?
So this volume is a bit configurable thanks to the RAD files using. I have a small slide about this. RAD files. So by default, our tool uses the default collect D values. And so it it archives the last week with 5 minutes resolution, the last month with 35 minutes resolution, and the last year with 35 minutes. And with these values of resolution, if you save one variable in the file, you have a file that will be about 170 kilobytes. Two variables, you will have about 300 kilobytes per file, and if you have 12 variables in your file, you will have about 2,000 kilobytes. So then from these values, you can extrapolate the volumes that will be taken depending on the size of your file system, the number of file systems you want to monitor, and that helps. It's easy to calculate the size. The point that is great about RD files is that they don't evolve in time. Once it is created with its size, and this size will never move.